In the previous lecture, we finished this example. The first example about mechanical vibrations. And now we have another example about mechanical vibrations. It says a 3 kilogram object, we have a 3 kilogram object, is attached to a spring and it stretches the spring 392 millimeters. Here, if we have a spring and 3 kilogram object is attached to the spring. It stretches the spring 392 millimeters. Okay. There is no damping. Before we write down what's the value of damping, I'm going to write down the general form of the equation. We say M was the mass, Y double prime plus BY prime plus KY equals F of T. Here M is the mass, B is damping, K is the constant of the spring. It says there is no damping, means B is 0. B equals 0 in the system. And a forcing function, the forcing function is the right-hand side, which is F of T. That means F of T equals 10 cosine 5T. Okay? Is acting on the system. The object is initially displaced 20 centimeters downward. Yesterday, we said that if displacement or velocity, if displacement and velocity are downward, means the value are positive. If this upward, the value is negative. And here we say the velocity is the derivative of the displacement. The velocity is the derivative of the displacement. We say the displacement, initial displacement means when time is 0, the displacement is 20. That means y of 0 equals 20. This is the displacement at the initial time. It's downward, so that means its value is positive, and from equilibrium position. And given the initial velocity, we have initial velocity. Initial velocity is the derivative of the initial, is the derivative of displacement. Velocity is the displacement of the displacement. You say if y of t to be the displacement, then dy by dt is the velocity. Okay, we can get velocity from the displacement by taking its derivative. Here it says the initial velocity is 10 centimeters second squared. Upward, it says it's upward. That means y prime of 0 equals minus 10 centimeters per second squared. This is y prime, which is the velocity at the initial time. And assume that the gravity G is 9.8 meters second squared. Let's give it. Hey, write down the governing equation of the above spring system. The governing equation is down, which I have written down by putting M, B, and K in it. Okay. And then find the displacement at any time. That means find y of t. After finding the governing equation, which is the second order differential equation, we solve it. The solution is the displacement at any time. And also it says, this a note, the spring constant K is given by K equals mg over L. Here, L is the length of a stressed spring, G is given, which is 9.8, and M is the mass, which is 3 kilograms. Now, we are going to write down all the given things, all the information from the example. We say M equals 3 kilograms. We have given this. I also have given that L was the stress spring, the length of the stress spring, which is 392 millimeters. But we should write down the standardized units. I mean, we should unify the units. If one of them is meter, the other one is centimeter, and we have millimeter, we must write down all the same. Okay, we must unify the units. We have millimeters, centimeters, and meters also. We have these three. Centimeters is in the displacement. We have in the displacement, and also in the initial displacement and the initial velocity. I also have millimeters in the stress spring, which is 392. These all are units of length. So we must write down all with the same unit. 392 millimeters. If you convert it to meter, what we do, we divide by 1,000. That means 392 divided by 1,000 equals 0.392 meters. So you get 0.392 meters. That's the length of the stress spring, which is L. Here, L is 0.392. As you have no damping, means B is 0. B is the damping coefficient. And also, f of t, which is the right-hand side, it's 10 cosine 5t. It's 10 cosine 5t. We also have given that the initial displacement is 20 centimeters. That is 20 centimeters, means y of 0 is 0.2. As I said before, y of 0 is 20 centimeter. To convert this to meter, we divide by 100. If we divide 20 by 100, we get 0.2. So y of 0, which the initial displacement is 0.2. And the initial velocity, we said y prime of 0 equals 10 centimeters. To convert this to meter, it becomes 0.1 meter. But here it's negative. Why? It's negative. Why? Because it's upward. But the displacement is positive because it's downward. Here, we should find K. We should find K. K is given by this equation. We have given M, G, and L. M, G, and L. M is 3 kilograms. G is 9.8. And L is 0.392. Here we say K equals K equals M is 3 times G is 9.8. Multiplying by, dividing by 0.392, which is L. It equals to what? This is 75. Yeah. It is 75. That means K is 75. We now have given all. First, let's write down the general form of the equation. We say M y double prime plus B y prime plus K y equals f of t. We have given all the unknowns, M, B, K, and F. These all are given. What's M? M is 3. That means the governing equation becomes 3y double prime. B is 0, so you have no y prime because its coefficient is 0. And B is, as you have no damping, means B is 0. Then plus K is 75. Y equals f of t is 10 cosine 5t. This is the governing equation. Okay, this is the governing equation for that example. It's written down here. This is the governing equation. Now, to find the displacement at any time, that means we should find y of t equals to, we say y of t equals the homogeneous solution plus particle solution. Since the right hand side is not zero, we have f of t which is not zero. That means here we should find both homogeneous solution and particle solution, and the sum of them is going to be the displacement at any time. Let's do it. We have given, now we have this equation. We are going to work on this equation for finding it. We say 3, we are going to write down the characteristic equation. It's 3m squared plus 75 equals 0. Okay, this is for the homogeneous part. We just let the right hand side to be 0, and we replace y double prime by m squared, y prime by m, and y by 1. And as you have no y prime in it, we just replace y double prime by m squared and y by 1. And here we get m squared equals minus 25. That means m equals plus minus 5i, is it? And the real part is 0 here. I mean, alpha here is 0. Alpha is 0 and beta is 5. And the general form of the homogeneous solution, if the characteristic equation has 2 complex roots, we say it is y equals e to the power alpha x times a cosine beta x plus b sine beta x. Here we just replace alpha and beta by their values. When we replace alpha by 0 here, we get 1. And beta is 5. We just replace beta by its value, and alpha by 0. E to the power alpha x becomes 0, becomes 1. So the homogeneous solution is a cosine 5x plus b sine 5x. This is the homogeneous solution. Okay. Now we try to find the particle solution. For the particle solution, since the right hand side is 0, we say for the right hand side, we say it's 10 cosine 5x. Do you have similar terms between this and that? I mean, if we let yp to be, sorry, let me write down it. I've written to here, as you see, it is a c sine plus d cosine of the angle, of the same angle. And in that case, that's it. Yes, it's exponential one. So the sine and cosine one, here we have no that case. Let me find it. This is for polynomial. No, it's case 3. That's it. We say if the right hand side to be either sine or cosine, for the particle solution, we choose this. We choose this for the particle solution. And you have x to the power r times c sine beta x plus d cosine beta x. We say it's x to the power r c sine beta x plus d cosine beta x. That means if either the right hand side is sine or cosine, we use this one. We choose this one for the particle solution. Okay, we don't care about the right hand side, it's either sine or cosine. Even if it's sine or cosine, we use the same. That means here we say the for finding the particle solution for that example, we let yp to be, this is for r to be 0, okay? We see the general form is x to the power r c sine plus d cosine, okay? It's the same. Here, the angle is, the angle of the right hand side is 5t. So you see it's 5t. T. Now we choose the suitable value for r, but we always must start from 0. We let r to be 0. If r to be 0, then yp equals c sine 5x plus 5t plus d cosine 5t. Do you have similar terms between these two and the homogeneous solution? Yes, there is similar terms. There are similar terms. So that's why what we say, we choose r to be 1. We choose r to be 1. Okay? If r to be 1, what we get? We get yp equals x times c sine 5x. So if this t, we should write down for t, okay? Because our independent variable is t. So t sine 5 is tc sine 5t plus t d cosine 5t. Do you have similar terms between these two and the homogeneous solution? There is no similar terms, because in the homogeneous solution we just have a sine and b cosine. We have a constant which is multiplied by the sine and cosine function. But here we have a variable which is multiplied by it. So in the homogeneous solution we have no t which is multiplied by the sine and cosine function. But here in this particular solution that we choose, there is t which is multiplied by both sine and cosine. That's why here we say there is no similar terms. Now we are going to solve it. We are going to find the particle solution. For the particle solution, we say we let r to be 0. If r to be 0, yp equals c sine 5t plus d cosine 5t. We have similar terms. So we let r to be 1. We have similar terms in that case. We now choose r to be 1. We say yp equals t, it's t c sine 5t plus t times d cosine 5t. No similar terms. In this case, we have no similar terms. Now, what we do? We are going to find the values of c and d. How? By taking derivatives and returning it to the differential equation. Our differential equation is y double prime, 3y double prime. Look, this is our differential equation. 3y double prime plus 75y equals 10 cosine 5t. 3y double prime plus 75y equals 10 cosine 5t. What do we need to replace here? We need y and y double prime. Y is this. And y double prime of p, I'm going to find it. We should first find y prime, then y double prime, okay? We say y prime of p equals, here we have t times sine 5t. It's multiplication of two functions. So you apply the product rule. For the second term is also, we have t times cosine 5t. We apply the product rule also. we have t times derivative of sine 5t is 5, so you get 5ct cosine 5t plus c sine 5t. Okay, now we are going to find the derivative for the second term, t times cosine 5t. This minus 5 dt cosine, so it becomes sine 5t. It's first times derivative of the second. Then second times derivative of the first is the second term itself. It's second function itself. D cosine 5t. That's all. This is the first derivative. And then we find the second one. We find the second derivative. Y double prime of p equals first times derivative of the second, then second times derivative of the first. This is only one function, we find it directly. And here we have multiplication of two functions, minus 5d times t, and also sine 5t. And this is only a function. We find its derivative directly. Okay, let's find it. Y double prime of p equals 5ct times derivative of cosine 5t. Derivative of cosine 5t is 5 minus 5 sine 5t. So it becomes minus 25 ct sine 5t plus second times derivative of the first. Derivative of the first, we have 5ct. We find derivative with respect to t, we get 5c. We get 5c cosine 5t. Here we have plus derivative of sine is cosine plus 5c cosine 5t minus. Here we also have derivative of two functions. One times derivative of the second plus second times derivative of the first minus. In a bracket, we are going to write down in a bracket because this negative signs for all. First times derivative of the second, which is 25 dt cosine 5t plus second times derivative of the first, which is 5d sine 5t. Derivative of d cosine 5t is 5. Let me close the bracket. Then plus 5d cosine 5t. That's all. Now we enter the negative sign to the bracket. This becomes negative. Okay? And also this becomes negative. I'm gonna delete this part of the bracket. Yeah, it should be sine. Yeah, thanks. 5d plus 5d is sine 5t. Now, what we do, we are gonna return y double prime and y to the differential equation, to this differential equation. Okay, we say put y and y double prime into star. And then we find the values of C and D. Okay. Let's check if there's any simplifying it. Here we have 5c cosine 5t and 5c cosine 5t. These two. So it should be D, I think. No. Okay, that's it. This is 10c cosine 5t. Okay, and let's check if there's any simplifying it more. Here, this is 5d sine 5t. 5d sine 5t, these are constants. Okay, that means here y double prime of p equals minus 25 ct sine 5t plus 10c cosine 5t minus 25 dt cosine 5t. Okay? Then now we put y double prime and y into the given function, given differential equation. We get y double prime is this one which we found now. It's minus 25 ct sine 5t. Plus 10c cosine 5t minus 25d t cosine 5t. Then here we multiply this all by 3. Okay, we multiply it by 3. Then plus 75 times y. Y here is yp. We choose yp to be this. We replace y by this. As we have 75 times y here, we replace by y. This tc sine 5t, td cosine 5t. See, dt sine 5t plus c, sorry, plus dt cosine 5t. Let me check if I have done the same. Okay. It equals to what? Equals to the right hand side. And the right hand side in the differential equation is 10 cosine 5t. Now we simplify the left hand side. We enter this 3 into the bracket, and we also enter this 75 into the bracket. Here we get minus 75 ct sine 5t. And here we get 75 ct5 sine 5t. If you multiply 3 by this and 75 by this, we get the same. Is it? We get the same. Here we get minus 75 ct sine 5t. Then we multiply it by the second term. It's 30 plus 30 c cosine 5t. Then multiplying it by this one, we get minus 75 because 3 times minus 25 is minus 35, 75. dt cosine 5t. Now we multiply 75 into the bracket. We get 75 ct sine 5t plus 75 dt cosine 5t equals 10 cosine 5t. Now we are going to cancel out the similar terms with different sign. This with this, I cancel out. Okay, and minus 75 dt cosine 5t and 75 dt cosine 5t, these are cancelled out. So it's left. This, write down small. This one with this one I cancel out. This one with this one I cancel out. Yeah, so you get 30 cosine 5t equals 10 cosine 5t. So why do you have to know d? So here c is 1/3 actually, but Why don't we have D here? We should have D also. Okay. We may have a mistake during the differentiations. Let me check. In derivatives of D here, it's minus 25. It's cosine plus this one. Minus. Sorry, this is minus. It becomes negative. It's minus 5. So these are not cancelled out and becomes 10. So here it's plus. It's plus 10. Sorry, minus 10. It's minus 10 D. 10D sine 5t. You have that also. So I have written down the 10 is 10 sine D sine 5t. So at the end we have 10. So here we have also 10 plus minus 10D sine, sorry, here you have it, minus 10D sine 5t, okay? And here also you have minus 30, as you see it's minus 10, if you multiply by 3 it's minus 30, D sine 5t. And you also here have minus 30 D sine 5t. It equals to 10 cosine 5t plus 0 sine 5t. That's it. Now we equal the coefficients to each other. That means 30c from this. We say 30c equals 10. And so C is 1/3. And minus 30 D equals 0. So D is 0. That means the particular solution YP equals what? Equals to, this is the chosen particle solution. We replace C by minus 1/3 or 1/3. It's minus 1/3, no, 1/3. C is 1/3 and D is 0. We get T times, so you get 1/3 sine. So it goes on. What's that? It's sine 5t. Here 3 sine. This is the particle solution. Okay? Now you have the particle solution. Then we say the solution y of t equals to what? Y of t equals to yh plus yp. You found the homogeneous solution before. And we said that it is a sine 5t plus b cosine 5t plus the particle solution is t over 3 sine 5t. Now we apply the conditions. We have given that y of 0 equals 0 and y prime of 0 is, so it's 10. There's 0.2 and minus 0.2. Y of 0 is 0.2 and y prime of 0 is 0.1, negative 0.1. We apply these two conditions. That means y of 0 equals what? We replace y by 0 and t by 0 also to find the values of a and b. We do this for finding the values of a and b. That means We say for y of 0 to be 0.2, it equals to. We replace y by 0.2, but t by 0. That means here we get a sine 0 plus b cosine 0 plus 0 equals 0.2. That means b equals 0.2. Yeah, this is 0, cosine 0 is 0, and this 0, we just get b cosine 0 is b equals 0.2. That's b. And now for finding the value of a, we apply the second condition. We should find y prime of t. What's y prime of t? This is y of t. We take the derivative for that function. We take the derivative for that function. Derivative of a sine 5t is 5a cosine 5t plus, it's minus 5b sine 5t. And here we have multiplication of two functions. First times derivative of the second plus second times derivative of the first. First times derivative of the second is plus 3 over 5. Sorry, 5 over 3, no. It is 5 over 3 t cosine 5t plus. This first times derivative of the second. Then second times derivative of the first is 1/3 sine 5t. This is y prime. Here we say y prime of 0 equals minus of 0.1. That means we replace t by 0 and we equal this to minus of 0.1. If you replace t by 0, this term becomes 0 and this term becomes 0 because here we have sine. And this also becomes 0 because we have t times cosine function. If t is 0, so it's 0 also. And here we say 5a equals, we just get this, we just have this one. Because all the other terms become 0 when we replace t by 0. We say 5a equals minus 0.1. And so a is minus 0.1 divided by 5, which is minus 1/50. This is a. That means y of t equals, we replace b and a by their values. So if b to be 0.2 means b is 1/5. 0.2 means 1/5. We say it equals, this is y. We replace a and b here. Y of t is minus 1/50 sine 5t plus 1/5 cosine 5t plus t/3 sine 5t. This is the solution. Vale. See? दाखिल नहीं बोलते दाखिल नहीं बोलते ऐसा है मच्छी मार के लिए ना इमाची मार के differential equation एक मान है हम differential equation ना दिन शिकार के बुके उधरावन के हैं दो condition मान जाओगे सरताय में अभी homogeneous solution particle solution दोसी homogeneous solution particle solution मान दोसी कोई हर दुनिया में बच्ची बुआ general solution إن جادي initial condition كان جيبتشي كم بس يا بدو سينو إن في كل سنة كان A بيت يعني y of 0 x سنة 0.2 y prime of 0 كان ناقص 0.1 أم دواني كهم من جيبتشي كم بدو سينو نرخي A B من دوسيو داني نلعب كشة كم من دوسيو أم بريتيلا شيكارك دفع تا هم أنجام كليه إن شاء هم أنجام الناس كتوتو كليه أوكي is 1/5 cosine 5t minus 1/t sine 5t plus t/3 sine 5t. So this is the result for that example. We now have another application of second order ordinary differential equations. Let's take a break for only 10 minutes. We now have another application of second order linear non-homogeneous differential equation. We have another application of the second order ordinary differential equation. It is RL circuit, RLC circuit actually. Here we say if you have an RLC circuit, you have V is the voltage, V is the voltage, and it's measured by volts. It's measured by volts. V is measured by volts. I is the current. It is measured by amperes. R is the resistance, which is measured by ohms. As V of A. L is the inductance, which is measured by Henry. C is the capacitance, which is measured by farads. And Q is the charge across the capacitor, which is measured by coulombs. Okay. The general form of the equation for solving an RLC circuit is L times di by dt plus Ri plus Q over C equals E of t. This is the general form. This is the general form of an RLC circuit. L times di by dt plus Ri plus Q over C equals E of t. And here we say I equals dq by dt. I equals dq by dt. Where Q of 0 equals Q naught is the initial charge, and I of 0 equals I naught is the initial current. These are the initial current and the initial charge. Initial charge is Q of 0, and initial current is I of 0. Here, in this equation, we have two dependent variables, which are I and Q. We have two dependent variables, Q and I. So we must solve the differential equation in terms of them. For one of them, we must solve the differential. Okay. Here we must solve the differential equation for only one of the dependent variables, which is either I or Q. Here we have this relation between I and Q, and we say I equals dq by dt. That means I equals Q prime. Here you have an example. It says the series RLC circuit. Be careful. In RLC circuit, we should use second order differential equations for solving it. We say the series RLC circuit has a voltage source given by E of t, which is 100 V. E of t is given. E of t is the right-hand side of the differential equation. It's the right-hand side of the differential equation. A resistor, which is R, is 20. Okay. Inductor is 10. Capacitor is 6,260 to the power -1. Now we have R, L, and R, L, C, and E. We have these four things. R, L, C, and E. We have given these four things in the example. We use that equation. This is the governing equation for the differential, for that application. This is the governing equation. Here we have given L, R, C, and E of t. We have given these all. If you replace these into the function, then we get, you say, if the initial current and the initial charge, we have given that the initial current and the initial charge, that means initial current is I of 0. and initial charge is Q of 0. It says both are 0. That means I of 0 and Q of 0 both are 0. Okay. So we say the differential equations become this. It becomes like this. If we replace L, R, C, and E of t, we get this differential equation. If we replace them into this differential equation, we get this. Okay, this is our differential equation that you work on to solve it. Now we have two independent variables, two dependent variables, which are I and Q. And you must solve it for only one of them. For one of them, either Q or I. And here we can solve it in two cases. We can solve it for I and we can solve it for Q. And in both cases, you must get the same result. In both cases, we must get the same result. But here we have given that I equals dq by dt. I equals dq by dt. Let's solve for I. Okay? Let's solve for I. So it's for Q. Let's solve it for Q. To solve this for Q, to solve this differential equation for Q, here we have Q. And you say I, we replace this I by dq by dt. How about the I by dt? We must find the I by dt here. We take the derivative for both sides with respect to I. With respect to t, sorry. We have I equals dq by dt. If we find the derivative for both sides with respect to t, the left-hand side becomes di by dt. And the right-hand side becomes, we already have the first derivative. And if we take the second derivative, it becomes d squared of q by dt squared. Okay. If we take the derivative for this side with respect to t, we get di by dt. And if we take the derivative for the right-hand side with respect to t, we get the second derivative with respect to t. And it becomes d squared of q by dt squared. Now, we replace di by dt by dq squared by dt squared. d squared of q by dt squared. I'm going to write down more clear. Yeah. We say I equals dq by dt and di by dt equals d squared of q by dt squared. That means you replace I by that and you replace di by dt by that. So yes. We replace I by dq by dt. And we replace di by dt by d squared of q by dt squared. Where? In this differential equation. In this one. In the above one. Okay? We replace I and di by dt by dq by dt and d squared of q by dt squared in the above differential equation. To have only q in the differential equation. As I said, we must solve it for only one of the dependent variables. It's either for q or I. Now, in this case, we are going to solve it for Q. And if you solve it for any of them, you must get the same results. Now, to solve it for Q, we must replace I and di by dt by these two derivatives. And we get d squared of 10 d squared of q by dt squared. We just replace di by dt by dq squared by dt squared, d squared of t by d squared of q by dt squared, and then we replace I by dq by dt, and we get this differential equation. We get this differential equation. As you see, you have only q in it, and q is the dependent variable. Now we can solve this differential equation as a second order non-homogeneous differential equation. Let's solve it. Solve this. Here we divide both sides by 10 to have only one here. That's easier. We divide both sides by 10 and we get this differential equation. Now to solve this, what we do, we are going to make it into two brackets, or we are going to use the quadratic law for finding the roots of the characteristic equation. Here we have a non-homogeneous differential equation, second order. If it's not homogeneous, so we must have both. We must find both homogeneous and particle solutions. We must find both homogeneous solution and particle solution. For a homogeneous solution, we say we let the right hand side to be 0, and then we write down the characteristic equation. This is the characteristic equation. SQH. This is the characteristic equation. We cannot make factorize this, so we use the quadratic law for finding the values of m1 and m2. That means here m is two complex values. M has two complex values. It's -1 plus minus 25i. It's -1 plus minus 25i. Here we say the differential, the solution for the homogeneous part is e to the power alpha t. What's alpha? Alpha is the real part. It's -1. It's e to the power -1t times a cosine beta t. Beta is the imaginary part, was 25. B sine beta t. This is the homogeneous solution. Sorry? Okay, M is the characteristic equation for this differential equation. We replace the second derivative by m squared. It's the same as y double prime plus 2y prime. Okay, I know. You mean, how do you get this? We say m equals minus b plus minus square root of b squared minus 4ac divided by 2. From this one we get it. Okay? If we replace a, b, and c by their values, a here is 1, b is 2, and c is 6. We get this result. So now we got the homogeneous solution. For the particle solution, the right hand side is a constant. So we just choose a constant for the particle solution. We say we let QP, which is the particle solution, to be C0. And in the differential equation, we have second derivative, first derivative, and the functions, the variable itself. I mean, we have the second derivative of Q, the first derivative of Q, and Q also. So you must have first, second derivative of the particle, of the choose particle solution. Here we choose QP to be C0. Then QP prime equals QP equals QP double prime equals 0. The first and second derivatives are both 0. And Q is C0. That means here we replace Q by C0 here. If we replace Q by C0, these are 0. And we get 626 times C0. Get 626 C0 equals 10. So C is 10 over 626. This is C0. So that's the particle solution. We now have both homogeneous and particle solutions. The homogeneous solution is e to the power minus t equals sine 25t plus b sine 25t. And the particle solution is 10 over 626. We say the sum of homogeneous solution and particle solution is the solution, is the general solution. This is the general solution. Okay. Now we apply the conditions. We have given two conditions. It says I of 0 is 0 and Q of 0 is 0. But here I of 0 means dq by dt of 0 is 0. This is the same as to say I of 0 is 0 because the derivative of Q, is the current. Derivative of Q is current. That's why you see we have that. So now we have two conditions. The conditions are I of 0 is 0 and Q of 0 is 0. I of 0 is 0. but we have no I in the solution. We have only Q. But I equals dQ by dt. That means Q prime of 0 equals 0. It's the same as that. Okay? You find the derivative of the solution, we get this. This is the derivative of the solution. We take the derivative for the solution. Why? To get I of 0. To apply I of 0 to 0. We should get I. We say I is the derivative of Q. So you find the derivative of Q to get I. Okay? So now we say I was the derivative of Q is this differential equation. Look, we first found the solution for Q. And to get I, there's a relation between I and Q. We say I is the derivative of Q. If we take the derivative for the solution, we get I. That means I is the derivative of the solution. That means I of 0 equals 0. So you replace T by 0 and I by 0. We get 0 equals this. And so B is minus 1 over 1,565. This is B. This is the value of B. And then we apply the second condition. We have another condition also. The other condition is Q of 0 is 0. This is Q. This is Q. We just here replace Q by 0 and T by 0. That's it. If Q is 0, here we get that A is minus 10 over 626. Now we have A and B. We found these two. If we put them both here and here, what we get this differential equation. This is Q of T. Okay? So I is the derivative of that function. I is the derivative of that function. What's this? This is I. Okay? That's I. So now we say this is I and that's Q. Here we solve the differential equation for Q and you got this solution. So what if we solve it for I? If we solve it for I, we have the second method. You can either solve it by that way, and also you can solve it by this way also. Here, we are gonna remove this Q here. How? We say I equals dQ by dt. I equals dQ by dt. That means we are gonna replace dQ by dt by I, and you get this differential equation. Okay. Ama? Say it. Unless you I got the C. dQ by dt. Derivative of how Chiman does it? I does. Oh, I'm on this go. Retailer. Basha. I derivative of Hamu Q will get you work I does. Oh. In Jai Saga Betu bu I Shikarikin. Katika bu I Shikarikin, Bahaman Rega, Haman Shtakin. Well, I'm little Q. And you said I can. Okay, this man I carry Q retailer. I'm a Q. I cheer. I is this. Where's I? These are the conditions. This I. As you see, we got the same result in both cases. You can either solve it for I or solve it for P, for Q. Okay, I'm going to leave the second method I mean solving it for yourself, for yourselves. Do it by yourself. It's done here. Let's just try to understand it. Even if you know only one of the cases, it's okay. We talk about to solve the differential equation for Q. Do you have any question about that? So it's the end of this chapter. Here you have some exercises about these applications. For the next week, so next week you have no midterm. For next week, you'll have an assignment. Okay? Yes, quiz also.
So you're going to upload it today first?
I'm gonna upload it by tomorrow because